Welcome. My name is Terrence Barkin, the Executive Director of the Advanced Carbons Council. We're hosting today's webinar on the use of verified graphene materials in textile applications. This has relevance for all other applications as well. So if you're not explicitly here to listen about the textile applications, this is still important for you to participate. I'll be joined today by Dr. Carrie Hill from ITA International, who will be presenting on some of the test results that we have performed on this particular topic. The Advanced Carbons Council is the successor to the Graphene Council, which was started all the way back in 2013. So we have well over a decade of experience working with these advanced carbon materials, which now include a much broader panorama. The Advanced Carbons Council is a trade association where we work with the companies that both produce and use advanced carbons in a very broad range of applications. We now reach more than 40,000 materials professionals worldwide that are engaged in the use and application and development of advanced carbon materials. By advanced carbon materials, this includes all of those materials you see in front of you here: graphene, carbon nanotubes, carbon fiber, synthetic graphite, carbon nanofibers, etc. Basically, we are focused on all engineered carbons. And one of the reasons we take this approach is a lot of these carbon materials can work synergistically with one another and can be used in combination. Whether it's companies that are producing multiple allotropes of carbon or companies that wish to use multiple forms of carbon, we can work with you to identify factual information about the supply chain and the technical aspects of all of these materials. To give you an idea, if graphene is something relatively new to you, graphene is really more of a family of materials rather than a very specific single material. And we have here a couple of examples with SEM, Raman, and TEM imagery and graphs for the different types of material. And this is just a snapshot. Excuse me. The Advanced Carbons Council has actually accumulated a database of more than 800 individual commercial forms of these materials. So you see here from left to right, few layer graphene, graphene oxide, which has up to 30 to 40% oxygen content. And then there's other forms of graphene like a turbostratic or shell graphene, which is in a clump, but the individual flakes are still graphene materials. And this is all to say simply that graphene can present itself in many different formats, but is very distinct from amorphous carbon, which does not have the crystalline structure, which Dr. Hill will talk about more in his presentation. Graphene is an exciting material that captured the imagination of application development specialists because it has all of the properties that you see here. Most materials can give you one or two significant attributes, and then there will be some corresponding trade-offs to be made. The very interesting thing about graphene is that it has all of these attributes, and we have seen repeatedly that when it's used in an application, like textiles, and yes, there is graphene in the shirt that I'm wearing, it's in that product. It offers multiple benefits at the same time, and in almost every case without any trade-offs in performance for the end application. This is what makes it very, very interesting. The other aspect of this, which is really important to understand, especially from the commercial perspective, is it takes a very small amount of graphene as an additive in a polymer or in a composite or any other type of application to impart positive benefits, often at less than 1% or even tenths or hundredths of a percent by weight addition to the host matrix. That's important from a commercial standpoint because the perception has been, at least for a while until now, that graphene may be prohibitively expensive to use, when in fact, because of scaling and efficiencies, the prices are coming down to be commercially relevant. And you add to that the fact you only need a small amount of it, it is definitely commercially viable to add graphene to get positive attributes in your end application. So that is no longer a barrier. At the same time, regulatory barriers have been stopping point for the use of graphene, and those have also been addressed. So where we are today, from price, scalability, and regulatory approval, we have a pathway to commercialize graphene on an industrial scale. And when we look at the range of applications where graphene can be used, it is really impressive because it has physical properties, electrical properties, thermal conductivity properties, UV, etc. It can be used in many different ways to exploit one or multiple properties. So in one case, you might be using it for its electrical conductivity, and in another case, you might be using it for strength or physical properties. Whatever the case, graphene has tremendous applicability across a really broad range of applications, and it can be used as an additive and an enhancing material for plastics, polymers, coatings, battery material, etc. But we're going to focus on the use of graphene in a textile application. And with that, I'm going to hand over to my colleague, Dr. Carrie Hill, who conducted a series of tests. And these tests have been done over a period of years now, where we've evaluated products that claimed to have graphene content in them versus product that we know has graphene in it. And this will be in particular for a textile application for hand protection safety gloves. And with that, Carrie, it's all yours.
All right, thanks, Terrence. So good morning, good afternoon, good evening, wherever you are. Thanks for tuning in. So as Terrence mentioned, I'm going to give a specific case study that we've performed on hand protective gloves. We do a lot of testing with graphene and advanced carbons, testing applications on the materials themselves, characterization, but then also, of course, these application-specific testing to verify whether the graphene or claimed content, additive content is present. So we'll go through this. Terrence, if you got the next slide. This is kind of a summary slide. I am going to go through this fairly quickly, the results, because it was a large study. We performed an initial study in 2024 and have published that. That second reference at the very bottom of the slide, you're welcome to copy that DOI number, or if you copy the title, you should be able to Google it and find it. So you can find more detail on the test methods there. I am going to discuss some of that, of course, here, but because I'm going to go through it quickly, I want to encourage you to follow up the slides or that publication to get more of the detail there. And then, of course, you can ask questions at the end. So the purpose of doing this work is to ensure that we have market integrity. As Terrence has kind of alluded and said, the graphene market is still fairly young, so it's important to ensure that when folks think they're using graphene, they actually are. When we have these products that come out and people say, oh, graphene doesn't work, it doesn't do anything. Well, oftentimes we'll find, well, it turns out there wasn't graphene in there. There may have been a different allotrope like graphite. There may have been nothing even related. You're not sure why that name got put in the first place. So third-party testing is important. We're not the only ones doing it. I think we are leading the charge in a lot of ways. I wanted to point out that there's others who are finding the same things independently. In 2023, there's a study there, that first reference in the bottom of the slide. We're a different group. We were not involved in this study. Characterized 34 different types of graphene oxide, just the raw material, and only found that 4 of those exhibited the claimed properties, whether it was compositional or morphological or whatever. Only 4 actually matched their description and their advertised properties. So our purpose here, of course, is studying the actual glove content, the whether graphene was contained within these gloves that we've tested. 5 gloves were tested at the point of that publication in 2024. Since then, we've tested 3 additional gloves. I'm going to steal my own punchline for sake of brevity and succinctness. We've only found 1 out of these 8 that have actually been proven. We can demonstrably show there's definitely graphene oxide or graphene present in this glove, as claimed. It's notoriously difficult to prove a negative. So in all scientific integrity, I want to say that we're doing our best effort here to make sure that we are evaluating these gloves to the best of our capabilities. And I'll explain why we feel like this rigor is sufficient as we get through these slides. But of course, we found that this one glove that we did test that did contain graphene oxide as advertised, it was unavoidable. It was very clear that the graphene oxide was present as claimed. Others, we have not found evidence. And I'll dig into the details here as we get into these next few slides. So what we did in these, we had 8 different gloves. selected from different markets around the world, representative samples, I believe, from different sectors. We extracted the gloves, we tested them as received, we looked at the fibers as received, looked at the rubberized material as received, and then extracted from the fibers themselves, performed dissolution through acid or solvent extraction in order to retain the graphene or graphene oxide. Graphene and graphene oxide would not be dissolved by these extraction methods, but the polymeric fibers would. And so the purpose there being that we're seeing the fibers as they're received. So if anything's on the surface, we should be able to see it and characterize it. If it's within the fiber, it's released and we're able to analyze it there. Our concentration was on the fibers themselves because that's where the advertised graphene content was located. We did not concentrate specifically on the rubberized material, though we did still analyze it. So just to be clear there, this is based on a fiber application because that's where the advertised material is presented. Our focus on the analytical techniques, we did Raman spectroscopy, which is a key characterization equipment for analyzing carbonaceous nanomaterials, including graphene. And then we did electron microscopy, specifically scanning electron microscopy with energy dispersive X-ray spectroscopy, which just means we do elemental, morphological, compositional analysis. So there are other analytical techniques that we pursue for other compositional characteristics as well. These two techniques, three techniques, 2.5 techniques, because some of them are combined, are what we generally use for this study. Next slide. So our extraction method, in a nutshell, what we've done is we've taken the gloves, we've analyzed, we've extracted the fibers, we've cut swatches, we've analyzed the fabrics as received, the rubberized material as received, and then also performed these digestions. More details are available in that publication, but succinctly and summarily, we would start in fully concentrated sulfuric acid. Depending on the composition of the fibers, that may be sufficient to dissolve the fibers if they're nylon-based, for example. Others that may be like HDPE-based spectra, that kind of thing, require a different extraction method with liquid paraffin at elevated temperature. All the details are in our publication. If you want the specifics, we can make sure you get them or you can find them there. And then we filtered the material to observe any captured particulates and performed our compositional analysis from there. So results for these. Again, I'm going to kind of go through and shotgun approach the results. This is not laid out in a comprehensive manner. It's laid out, and so I can just kind of point out the key characteristics that we found. The results are anonymized. We're not trying to shoot anybody in particular in this instance, but we want to make sure that we're just showing the general trends that we're observing. So glove B was one of the gloves that we observed that claimed to have graphene content. And you can see in those optical microscopy images, these little black flecks seem promising at first. The Raman spectroscopy, his is on the surface. Raman, depending on the material, the laser is able to penetrate to a certain degree, but it's not always definitive that it's going to penetrate well enough to get a signal from any graphenic content that may be within those fibers. So on the surface, essentially, we're just seeing the polymer content here. We're not seeing anything graphenic in this range, but we don't expect to either necessarily. So in the next slide, we have our SEM imaging of this fiber, these gloves. This is the as received glove before any extraction is conducted. And some of the interesting nuances here, this is elemental analysis. We're not going to be able to discern graphene in this particular characterization technique, but what we do see is elemental differences, which tells us things like those in that kind of top middle image is a backscatter image on the SEM, and you can see those kind of glowing fibers that are coming out, the bright white fibers. This is in backscatter mode where we see higher Z number, higher atomic number materials are going to show up brighter. And so that tells us that's a different material. And then we perform our elemental analysis, and you can see that these are actually, there's iron, there's chromium present, there's steel. So there's steel fibers, steel additives. There's also high silica content, silicon and oxygen overlapped, so silicon dioxide. These are traditional cut-resistant additives, which are fine to have in a glove. There's no need to only use graphene, but all this is to point out that this is the cut-resistant additives that we were observing in this glove, with steel fibers along with silicon dioxide embedded within the fibers themselves. And we performed our extraction, dissolved the fibers, and then the release material was analyzed. And again, we just found a lot of silica content. That was kind of the main takeaway. The steel fibers were also removed before this analysis here. They kind of came out in a big steel wool looking mass. And so we just pulled those out to look at the particulate additives. Did not find any evidence of graphenic content, found a lot of silica. Glove A was related from the same brand, actually. And this one, we did see evidence of graphite. So this is Raman spectroscopy being performed from an extracted bit of the mass of material from the fibers that have been dissolved. And if you're familiar with Raman spectroscopy, you'll look at those peaks, specifically the blue and teal lines there in the middle on the right side, and you'll see, hey, look, there's GD and 2D peaks. That's promising. Drilling down on the analysis here on the 2D peak specifically, you'll notice that it's a shouldered peak, it's a broadened peak, which is indicative of graphite, not graphene. Graphene would have a more single, less spread, less broadened peak. So we did not find evidence. This is not compositional evidence of graphene. It's more compositional evidence of graphite. And then I believe in some of the next slides, I'll have images here of some of the particles themselves, which we did find thick flakes of graphite as well for morphological evidence. Glove C, again, we see these kind of spots within. Raman doesn't reveal a whole lot. And the next slide, what we did find was evidence of carbon fiber. So this is one of the things that we found to be common. There are a lot of materials that, or excuse me, gloves that claim to contain graphene. They actually contain a different allotrope of carbon. To be clear, it may not be necessarily someone trying to mislead their customer. It may be that in some cases we've kind of found out that a glove manufacturer is buying from a supplier. We did find that two unrelated companies were buying from the same supplier graphene fiber for their gloves. And so it's important to verify your product. If you're a manufacturer who is looking to buy, graphene fiber from some other supplier who is producing the raw form, it's worth verifying because in some cases they may claim that it's graphene and it's not. And so we were seeing evidence here of potentially carbon fiber. There's an amorphous carbon fraction here as well that Raman spectroscopy was revealing in this sample. Glove D was a different glove that had a couple of different additives in it. We saw a lot of silica present in this one, which again, that's fine. Just no graphene was evidence by the morphological analysis. Next slide, Terrence. And what we did see though was a lot of glass fiber, which is just interesting. It's another traditional cut resistant additive. After we dissolved the fiber, we did not find evidence of graphene. What we found instead was other traditional cut resistant additives because we're not evaluating the performance. We're not evaluating the cut resistant performance of these gloves. We did not employ cut resistant methodology to determine which gloves perform best in those applications. We were simply verifying whether or not they contain graphene as claimed. This one, again, like most of these other gloves, had a different traditional cut resistant additive in there in place of the graphene. We did not find graphene in this one. Glove F, this is one of the newer ones we've added since that original study. This is just a view of the fibers. Nothing particularly to see here except for some additives on the surface that could be actual particles from ambient sources or from the production itself. And the next slide, we got the extraction. This one was interesting because we found titanium dioxide was present. So titanium and oxygen signatures overlap in that EDS spectra. So we're seeing titanium dioxide particles that were placed in there as the cut resistant additive. Again, no evidence of graphene in any of the work that we had done. And when I say this in all these slides, I'm not relying on just what I'm showing you here. I'm just showing you some of the highlights of what we found. We have other, of course, compositional characteristics that we analyzed to make these claims. And then the next slide, we've got this another glove that we analyzed more recently, which contained prolific carbon fiber. So the material there on the left image there, that optical microscopy image, that's actually after it's been dissolved, we've just extracted the remaining material from the glove fibers with sulfuric acid and then filtered. And so you're seeing these bits of carbon fiber that are stuck on the surface of the material. Carbon fiber does not dissolve in sulfuric acid, and so that's why it's able to remain, while the other polymeric material, in this case is probably a nylon of some sort, did dissolve. And so we have this carbon fiber there. You see those peaks. They're indicative of amorphous carbon. So some varieties of carbon fiber can be crystalline, others are amorphous. This was an amorphous variety. And then glove E, this is the one that actually did test positive for graphene. We did get a S verification opportunity, a sample of the graphene oxide slurry that was used in the production process. That was part of we performed our analysis first on the glove itself and then procured that sample so that we could do compositional verification. And sure enough, we found a match, a close match. So on the left side is just the graphene oxide material, the slurry that's used in the production process. And if you're familiar with the Raman spectroscopy, you'll see that characteristic G2D and then the double mediated slopes of the 2D on the right-hand side of the spectra. And then we found that the same signature, a matching signature in the particles that were recovered from those dissolved glove fibers. And then we see here in the as received glove morphological evidence of the graphene oxide. No compositional identification in situ here, but you can see the additive is embedded within the fibers and on the surface of the fibers, this flake-like material. So it's circumstantial evidence pointing towards the same conclusion. I believe we have more on the next slide. Oh no, I guess I cut out the slides. There are others were zoomed in. You can see more of the flakes in higher detail. To summarize, what we found here, again, only one of the 8 glove samples we've tested to date has been definitively shown to have graphene or graphene oxide, any kind of graphenic content. There were, in some cases, graphitic signatures. So again, in glove A and B, B was the example that we showed earlier in the slides. If you look at the paper, I think there's some evidence in A as well. Where we found sparing evidence, actually, it was kind of a rare occurrence that we saw these additives. And when we did, those peaks, the 2D peak is shouldered, which is indicative of graphite. And also we found concurrently, that's why we like to use multiple techniques to make sure we have concurrence between our techniques and not just relying on interpretation of one instrument. We did find that we have these thick flakes that were graphitic. And there's other techniques we use. We talk about in the paper in situ and the electron beam to make sure that we can know by basically jacking up the electron beam. And if it's polymeric, it'll burn. If it's graphite, it's resilient. And so there's other ways that we verify and more subtle methods that this is graphite content and it's carbonaceous, that kind of thing. So we did find some material there. Incidentally, I believe Terrence reached out to some of these companies and just said, hey, just so you know, you're saying it's graphene and it's not. This is important. Please change your claims. Some of them have been a little bit salty about that. Others have not. But I do want to point out that one of the companies that we contacted about this after doing our testing changed their website description from graphene to carbon allotrope, which is appropriate, and I appreciate that they did that because that's more honest. And it's not to say that the cut performance is lessened by that claim. We just want to make sure the claims are honest, and so that's the whole point. So we did not find through Raman or SEM any 7 of the gloves did not show any evidence of graphene content. Some showed some graphite, others showed prolific cut resistant additives such as steel fibers, glass fibers, titanium dioxide, silica. There's or maybe even silicon carbide, depending on the glove sample. So they're using other cut resistant additives. Again, fine to use in conjunction. Just make sure we're being honest. And last slide, just some conclusions about this. Overarching and kind of from a sweeping perspective, the reason we're doing this is to make sure that we have market integrity, right? We want to make sure that we're able to verify claims because any bad actor it's a fragile market. We can damage even in other applications. So certainly for textile applications, but also if someone hears about, oh, this glove said it had graphene and it doesn't, or this glove doesn't work well and it says that's graphene in it, rather, they might think the same thing for concrete or composites or vice versa. So it's important to make sure that it's being evaluated fairly. And if graphene doesn't work in an application when it's done well, that's the result, right? So that's fine too. And we just need to make sure that there's honesty and integrity in the market so that those who are trying to use these applications and provide solid material that is actually what it's claimed to be have a chance. So that's the point. We believe that the test methods we've employed are robust. Again, look through the papers. Welcome to feedback on that. We found prolific evidence in the case of the one glove that did have graphenic content, and no evidence that was substantially convincing in the remaining 7. And we're going to continue to do this. There are other sectors that we'll continue to look at. And if you have a sector that you're concerned about that you work in, reach out to Terrence and we will find a way to test that for you. We are keen on developing methods for testing materials. That's one of our kind of sweet spots here, that we are not a test lab that just gives you a typewritten response without units on this ugly looking page when, and then you hand us your money. We like to do a test that actually makes sense and actually is interactive and provides useful information. Lastly, just note that, carbon has a lot of different forms, and that's one of the reasons it's such a unique and important material, both biologically and in advanced materials. Graphene, we're now learning, is a family of materials. There's the traditional mindset is this kind of thin film, thin sheet graphene. But there are a lot of other morphologies that are coming about that are part of this graphene family. And Terrence had that slide a few slides before I got on, where you have these different types, where you have your thin film, traditional thin flake-like graphene. You have graphene oxide, which is a slightly expanded layer stacking because of the oxygenation. You also have these shell and turbostratic morphologies, onion morphologies, which are more spheroidal. They're like little balls of graphene, but they are crystalline, either in a shell form or in a turbostratic, kind of mediated, displaced lattice form. So, and these have different applications. Certain types of graphene are better than others for electronic versus composites versus rubbers versus whatever. So textiles. And so it's important to know what you're dealing with and which graphene is best for which application. And that's the part that we're working on next. That's the era we're entering, is how do we match the right graphene to the right application? Because it's more than just one type. It's like saying, well, I need metal for this application. Well, do you want steel, aluminum, titanium, super alloy? That's kind of what we're entering, it's a class of materials, a family of materials, and some types of graphene will be better than others depending on the application. So I think that's all I have here. Feel free to reach out to me if you like at some point. Anything related to advanced carbons, I work through Terrence, so you can talk to him. If you want to chat with me directly, there's my email address and contact info. We're based in Southwest Virginia, in Blacksburg, outside of Virginia Tech. We've got access to all kinds of equipment. We do all kinds of analysis. But anything graphene, advanced carbons, CNTs, that kind of stuff related, work through Terrence. So you can talk to him if you'd like, or reach out to me and we'll get you straight. And with that, Terrence, I'll turn it back over to you, and we'll be ready for Q&A at the end.
Perfect. Thank you so much, Kerry. That's a really good segue into the next part, and that's where we focus on standards, defining what is and what is not graphene, and we've made tremendous progress with that. What I want to show you here is there's actually 6 standards task force groups that we're working on at the moment. Graphene, where we now have an ISO standard. We are working on an update and evaluation of an existing ISO carbon nanotube standard. There's a draft standard for reclaimed recycled carbon fiber. Carbon nanofiber material, which is not a nanotube and it's not graphene, but it's in that family. It's very similar, is a new defining standard. Also for biochar, which is a carbonaceous material, which has non-agricultural applications. So we're focused on that. And one of the newest materials that's in the nano form is maxenes, or max phase materials that are then converted into a maxene, which has a carbide core and then a transition metal sandwich basically on the outside, is a new and emerging material. So you can kind of think of carbon nanotubes are 30 years old, graphene is 20 years old, and maxenes are 10 years old. And these materials are progressing through evaluation, production, scale up, standards, regulatory approvals, and we're involved in all stages. And in particular, I want to talk about the graphene classification framework, which was started by the Graphene Council a number of years ago now, in order to be able to classify and differentiate one distinct form of graphene from another. So combined with the ISO standards, and we are now, the next step is actually creating ASTM numbering system for distinct forms of graphene. The graphene classification framework lists which characteristics are important, what is a test method for each of the characteristic, what is an expected range of values for those test methods, a neutral, non-jargon filled syntax to describe the materials in a concise way to differentiate one type of graphene from another. And we've also developed a standardized technical data sheet so that the values can be reported in a consistent manner so that the consumer has maximum transparency and the ability to compare and contrast one material to another from different suppliers as long as they're using the what is now an ISO standard for not only the classification framework, but it includes the template as part of that standard. So that's ISO TS 9651, which was published rather recently after many years of work. So we're quite proud to see that that achievement. And all of the testing that Carrie had mentioned, so when we do testing, we focus on the testing now for this destructive testing for the hand gloves, but we do material characterization and testing. So if companies want to receive a technical data sheet for their material that is ISO 9651 compliant, we do the testing according to this standard, and we'll provide you with a technical data sheet in the format compliant with the standard. The other part of the puzzle here is verification. So it's one thing to test the material, but it's also really important in this sector to be able to verify the production of these materials. Of course, it is a minimum requirement that a company can produce what they say they produce, but companies in this emerging graphene Wild West also make claims about their capacities and scale. And so what's important for a sophisticated end user is to know, can a company produce what they say they produce, and can they produce it at the scale they say they produce, so that it can be fully commercialized on a large scale? Because if you're looking at putting graphene into polymers for textiles, the volumes are going to be significant. The same is true if it's elastomers for tires or for coatings or paints or batteries or whatever. To truly commercialize this material, it needs to be done consistently, repeated, and at scale. And so the verification program that is run by the Advanced Carbon Council, it is the only in-person inspection of these production facilities. And we have designations for the production of graphene. We have verified graphene products. So again, the company that produces these shirts, a company called Graphene X, it's a verified graphene product because it's been tested that it contains the graphene it claims it does. And functionalization is another specialty of adding value to a graphene material by intentionally altering it, adding some surface treatment or whatever the case might be for functionalization. And we have a verification program to designate that as well. So the verification program involves our review of raw material intake, how this material is stored, whether there are hazardous materials that are involved or not, and that they're handled safely. We look at the production process. And part of that is to evaluate whether the process is able to be scaled industrially. What is the capacity claim, the legitimate capacity claim for a production facility, including downtime and maintenance and repairs and everything else, so that we know what the true capacity is. We look at the health and safety practices in that facility. Any nanomaterial, doesn't matter if it's carbon, which is pretty benign, or other allotropes or forms of nanomaterials, you want to be careful about exposure and inhalation and that sort of thing. Graphene is benign for dermal contact, but you don't want to inhale any nanomaterial. So we look at the health and safety practices in the facility, including the waste handling or disposal. Further, we go and we look at quality control processes. Is it well documented? Is it followed in the facility? And we go all the way from the raw material until that material is ready to be shipped out. And we look at what kind of packaging is used and how it's handled in the packaging and before it's shipped and goes to the customer. And then after all of that process, we take a sample directly from the production stream, so we know that we have chain of custody, that the graphene that we're testing was actually produced in that facility, as opposed to somebody sending you a material claiming they produced it, and then you have to go on trust. We verify by taking a sample while on site, and then it goes through the rigorous characterization that Carrie's office does. And the sum total of all of those evaluations, quality control, health and safety, production volumes, etc., and the audit of the material results in either a pass or fail for a verified company. And so that's what the verified graphene producer or verified functionalized company or verified graphene product designation means. That means a company's gone through all of these processes and has successfully passed that. So with that, we're going to move to Q&A. I just want to point out, if anybody is not a member of the Graphene Council, we are here for companies that make these materials, and we're here for companies that use these materials so that we can connect an appropriate supply chain partner with an appropriate customer, and we can give you independent, neutral, expert advice with science and materials experts on your application development so that you have a successful outcome. And that means you're actually using graphene and you're using it in the correct way. And that's what we're here for. We are a neutral body. We have no interest in any of the graphene companies. We don't get commissions. We are completely independent and neutral from that. And as I like to say, we love all of our children equally. We have no favorites here. We'd like to work with anybody who's interested in this material. And our objective is to make sure that you have a fact-based guidance on how to deploy these materials. For any information about the Advanced Carbons Council and how we work, and that includes across all the allotropes of engineered carbons, feel free to reach out to us and we will certainly answer your questions as best we can. All right, so then Carrie, it's you and I, and we're going to go through the Q&A here. Again, I want to thank Carrie and his office for the excellent work that they do in the testing, and especially when you're dealing with nanomaterials, it's virtually impossible, even for sophisticated end-use customers like chemical companies or plastics companies, to actually know if they have graphene or not, and that's where I think we can help. Let's go through some of these questions here. The first one, how can we apply graphene on a non-woven needle-punched sheet? So I have some ideas on how to answer that. Carrie, I don't know if you want to give a shot at that, or you want me to take that one.
Yeah, I was gonna say it depends on the application. You probably have a better answer than I do, Terrence, because I think that one of the things that Terrence I know has in the council is folks who do some of these master batching and application specific functionalization. So depending on the graphene, depending on the needle punch sheet type, the composition, and the application, there'll be different methods. But from an industrial perspective, Terrence has the connections for folks who really do this well. So that's all I'll say there. There's more specifics probably that could be getting into, but Terrence, you probably have a better answer than I do as far as a practical answer to that.
No problem. So it depends on what the host material is, but graphene is quite compatible with the entire family of plastics and polymers. It works quite well in film form, and that's when the graphene is actually incorporated into the host material. The other option is applying graphene as a coating. And I know with some textile applications, the approach has been to apply graphene as a coating on an existing textile. It's more effective if it's actually incorporated into the host material. Depends what properties you're trying to achieve, if it's improved strength or better thermal transport. So for example, with a textile like this, especially that you're wearing, the thermal transport, the feel, the comfort of it, the wearability of it, these are all important factors. And those are reasons why you would use graphene in these applications. So in the case of a non-woven, there are lots of applications for graphene in a non-woven. And normally it's because it's incorporated at the time of production when you're making the film or the sheets. That's normally how you would do that. For the next question, Carrie, for you, Carrie, you mentioned that you analyzed as a fiber. If one customer is incorporated in resin graphene, but we'll have to discuss what that means, but graphene oxide is not chemically connected with the fiber, how can you say that you don't have graphene? I'm not sure if I understand the question exactly, but
Yeah, I think I understand. So basically, if we have it in a different system that's not in a fiber, but instead is in a resin, can we basically apply similar methods? And how can we be sure that we have it analyzed appropriately? I think I get that, and the answer is a similar methodology would apply. The dissolution of the resin, the decoupling of the resin is going to depend on the composition. Resins can be trickier because they tend to be, cross-linked, maybe harder to dissolve, for instance. But if the graphene or GO is not chemically connected, then it will also be released by those extraction techniques, and then recovered through the filtration or through the cast and centrifugation. There are different methods we can employ depending on the system to analyze. So I hope that answers. It's kind of basically a similar or modified technique would be employed that would be similar. We would use similar analytical techniques, but depending on the system, depending on the resin. We may need to make some adjustments to make sure that we've got the right way to release the material. If it's not chemically connected, then it should be released from the extraction process anyways. And like I said in the beginning, it's difficult to prove a negative. Proving there is not graphene is difficult. If we know already what the claimed percentage and concentration is, then that makes it a little bit easier. But this kind of technique, we should be able to see it if it's there at any appreciable content. So if it's and appreciable, I mean, like as Terrence mentioned, we use low amounts in most graphene applications. So 0.1 to 1 weight percent. That's what we're talking about. That's still a significant amount. So I hope that answers that question. I think it's certainly feasible in a resin, just like in a fiber. There'll just be some modifications required.
Absolutely. And, we should point out that what we're highlighting today was a very specific test on textile hand protection on gloves. We've done testing in other materials. For example, face masks, we did tests on that. The same thing is to detect if there was any liberation of graphene. That's another way of testing, is you want to know if there's any shedding of graphene from the textile, for example. That's something else that carries facilities are able to do very well in a class 1000 clean room, is to detect if any graphene material is being shed from the textile, if that's of interest or importance to you. There's a lot of different techniques that we can use. Another question that we have here is, can this analytical approach be used to do some kind of quantitative analysis regarding the loss of graphene in textiles, for example, after washability? So I'm assuming, we tested on day one, it's never been washed. We test on day two after 20 washes. We test after 50 washes, and you see if there's any appreciable less content of graphene in the material. You talked about the qualitative analysis. Is it in or is it not? Can you talk about the quantitative analysis?
Yeah, for sure. So this is a great question. The answer is yes. I would use a different analytical approach for that instance because, as we mentioned, this is a qualitative, is it there kind of analysis. We weren't trying to be quantitative in this. However, the extraction process, once we do some assessment on percent recovery, for instance, it could certainly be used for quantitative in a similar manner. That may not be the approach I would take for this specific instance. Depending on the textile itself, it may be better to do a thermogravimetric approach, for instance, and in order to be able to measure that. If it's a low loading, that might be difficult because of ash content, that kind of thing. The bottom line is there are different ways to go about this. But this doing a quantitative analysis is always going to be a little more nuanced than doing this kind of qualitative investigative approach. But there is a route to do that. And there's two different angles. One being following a similar methodology to what we just described, but having some more careful control over retention of the material that's obtained, or, like I said, using a different approach like thermogravimetric analysis to retain the non-ashed portion of a textile with graphene in place. The second approach would be, as Terrence alluded to, an exposure assessment. So if you're looking at release, we also have done quite a bit of leaching studies, extraction studies. My lab is actually originally set up as kind of an exposure analysis group. I'm a materials scientist, but we're kind of focused on toxicology and exposure, and we're kind of getting back into more of the roots of material science and characterization, which I love because that's my roots. But that's what our shop is set up to do. So we have done some leaching assessments, extraction assessments for things like EPA and FDA clearance. So that's another approach where, if you're looking at rather than looking at the loss in the material, you can look at the how much material is extracted into the water or the solvent. So that's another way to approach that same issue and kind of assess how much comes out. Therefore, that's how much you lost. So different ways to approach that one. But yeah, some methodology would be appropriate to do that. That would be feasible.
Excellent. The next question I really like because it's kind of gets to the heart of all of this. The technical analysis is really important, but the question is, what are the main benefits you can get from graphene within a textile? Is it strength, thermal conductivity, electrical? I don't know. Can you give some examples? Thanks in advance. So we appreciate that question. It is really important because in the textiles, you're looking at much, much better wear characteristics. So you've got a longer lasting, more sustainable textile. You have a better thermal comfort level for the wearer. You have antibacterial properties. So you have a more hygienic textile or material that you have. So all these things are really important. And we've seen where brands really need to differentiate from one another, having graphene in it to improve the performance characteristics for all of the methods that I just mentioned, or the characteristics, is important. But this comes back then to how do you differentiate between other companies that claim to have graphene in it but don't. And this is why we have the verification program. And so if you're a brand and you want to incorporate graphene because it gives you a superior product, the way to do that, in our opinion, would be talk to us about having the verification process for your product so that you can label it. And we, as an independent third-party expert testing house, can verify and make the differentiation between companies that actually use graphene in their product and those that don't. And what you've seen from the test results that Kerry mentioned, he's correct. For the companies that were using or selling product that claimed to have graphene in it, and we could not verify that it had any graphene whatsoever, we did inform them of our findings and gave them copies of those test results. And the risk then for a company that continues to advertise as having that material when it's not present has a false claims liability potentially against them. And it's also just not good practice. At the same time, I want to say that the vast majority of those companies, I assume, simply bought textiles that they were told contained graphene in it. They used it, they advertised as such, but they did not verify it. And so once they're aware that they actually do not have graphene in their product, it's a problem on two fronts. One, of false advertising, if they're aware of those are the actual cases. And secondly, they're just not delivering the product that they think they are. And that's important for us to make sure that there's integrity in this market. And if people claim to use graphene, we want to make sure that it's actual bona fide material because it works, because it provides an improved textile product in the end. So with that, thank you for that question. That's why you use it, and also why it's important to make sure that you can differentiate from your competitors if you choose to put graphene into your products. Another question is, can we ash the sample and identify whether this is GO or not? Kerry?
Yeah, I think that's feasible. It depends on some of the characteristics of what the material is. I was starting to type out an answer, but I'll say it now. Essentially, you could use TGA. Depending on the atmosphere you use, graphene tends to, and graphene oxide, they can combust. They can oxygenize in a oxygen-containing atmosphere and burn, just like an organic, but usually at a higher temperature. So for graphene, for instance, off the top of my head, I can't remember where graphene oxide will start to do that, but graphene will start to combust at like around 600 C. Whereas organics tend to be quite a bit lower. So that would be one way to do it. If you know the ash content, which for certain fibers, polypropylene, that kind of thing, polyesters, usually that's a fairly well-known characteristic, how much carbon residue is going to remain after ashing. So that would be one way to do it, depending on loading percent. Resolution may be a little funny, but you may be able to find a way to do that as well. Under an inert atmosphere, graphene and graphene oxide aren't going to start to decompose until closer to 1,000 C. So that may be another way to do it. So the answer is yes. There's obviously nuance depending on the specific application, but that would be a feasible way to do it. And also determining the difference between graphene oxide. These are elemental carbons versus organic carbons that are present in a polymer fiber. So there are certain methods of analyzing elemental carbon versus organic carbon, which if you know that's what you have and you don't have other types of elemental carbon present, then that's a way to go as well. So yeah, absolutely.
Excellent. We have a number of questions still coming in, so we'll continue doing the Q&A here for a little bit. We appreciate everybody who's sticking with us as we go through this. But hopefully this is helpful to you all. One comment or question came in is I'm a yarn agent. I sold a few hundred kilograms of a material that had 0.5% graphene. It was for socks and for cycling shorts. Final customer didn't feel any difference with or without the graphene. They said it's only marketing. The main question is they were concerned about the quantity. Now, typically what happens, and I can understand perhaps what happened here, if you're getting a graphene infused yarn, first of all, I hope that what you got is actually a graphene yarn. That would be the first question, because in testing, especially out of China and some other markets where we've seen some of these textiles come out claiming to have graphene, they don't. So maybe you didn't even have graphene. That would be the first question I would ask. And then secondly, when you're making a blend, if you're using graphene enhanced fibers or yarns and you're blending it down where it's a small percentage of the overall textile, you're really diluting the possibility for the graphene to have an impact. So it is a question, and typically it's not 100% graphene infused yarn. It's a graphene infused fiber or yarn mixed in a textile. It depends on the percentages. And if you get too low a percentage, it doesn't matter. It's not going to make a difference. And that's common sense. You're using too little of the material to get the effect that you want. So one, did you actually have graphene? That should be verified somehow. And secondly, in the blend, are you blending it so low that you're diluting the impact that it would have had normally? Because we do know that it works, and there's independent testing about mite resistance, thermal transport, antibacterial properties, wear resistance, all of these, like significantly improved wear resistance. Think of outerwear, and there's applications where graphene enhanced fibers are being used by military applications, which has obviously a high standard of durability. These are all applications where it is being used, has been tested, and there are test results. Another question is, do we know if any of these materials are used in rope or cordage applications? The short answer is yes, for all of the reasons we talked about. And in particular, if you think about friction and wear on cordage and think of commercial shipping ties, ropes, basically, then friction and wear is an important characteristic there, and that's in particular where that can help. Another question, is there a project to have a certified label graphene inside, or those that contain graphene? We do have the Verified Graphene Product Program, and talk to us, because we can provide holographic stickers that would go on the garments themselves and designate it. And we keep a registry of which companies have verified product. So we can help with independent third-party listing of that and verification, and we can help you badge your product as a verified graphene product. That exists today. So please reach out to us. Another comment, I have a few pairs of pants from Graphene X. I have a whole bunch of clothes from Graphene X because it works. Actively shopping for other items for myself and my family members. Is anyone doing side-by-side comparisons from various retailers? That is not a test we've done. There are dozens of brands. Yeah, we're always happy to test. No problem. There are dozens of brands that use graphene in their product. Graphene X has been a longtime member of the Graphene Council and now the Advanced Carbons Council, and are using the Chirene fibers. That's from Graphene One, known as Chirene, or Armor Guys is the hand gloves. That they are a verified graphene producing company and producer of those materials. But we haven't done side by side yet, but we're always open to that. How to distinguish graphene nanosheets, graphene oxide, and graphite from Raman spectroscopy? Carrie, that's yours.
Yeah, so there are several spectral characteristics that are present for each of these, and I can point you towards a few academic papers if you need to follow up. If you Google it, you'll probably find some academic papers that will show side by side that are excellent, that are good for example. But you will see differences, and there's G peak, D peak, 2D peak in those regions. Graphene and graphite can look similar, and if it's a true, pure, pristine, so the one caution I want to add here, if it's a pristine, flake-like or film graphene, then you can do things with the G to D ratios and determine some characteristics about layer counts and that kind of thing compared to graphite. I caution against that in powder form because you have edge effects. And there's an excellent paper from NIST about this that was published a few years back. That they're introduced that can cause confusion. The short version, though, is that Graphene and clean graphite can look similar under Raman, but you will see a shoulder 2D peak in the 2D region on the graphite. And there'll be some other characteristics that can be discernible as well. Graphene oxide is a very distinct, it's got an amorphous looking, it can look similar to amorphous carbon, but it does have some smaller peaks in the 2D region. So anyways, to summarize, there are several academic papers that can point you in the right direction there to show for the actual spectra. There are spectral characteristics that are distinct between them. It does sometimes take a little bit of investigation, especially when you have other materials present, because there can be some conflagration of those spectra. But I think that answers the question. There are several reliable resources out there from academic papers that have been published where people took very pristine samples and kind of very carefully characterized to show those differences.
Excellent. Thank you, Kerry. Another question was about how often we conduct these in-person inspections in the validity period. So the in-person inspections are conducted, the material is tested. The verification is valid for a company for 3 years if they maintain their production process, and we track that on an ongoing basis. I can tell you all I do every day is talk to graphene companies, and we track and follow what's going on in the market, including feedback from customers about different companies and their business practices and their material, whether it's performing or not. We maintain a database of over 800 technical data sheets, and we continuously update that every 6 months. We're reviewing that and keeping in touch with these companies. So that the verification is for the company, and the testing of the materials is the audit. And every 3 years, companies are then re-verified with an inspection period again through their process to make sure everything that they've been doing has been maintained at those standards. Another question is, how advanced is the integration between high tenacity textiles such as Kevlar or Hericon and graphene oxide for ballistic applications? And I would say not necessarily just graphene oxide, but other graphene materials are being definitely used in ballistics applications as part of a sandwich. So you might have Kevlar, but you'll have another high density polyethylene or another type of polymer that's been enhanced with graphene because of its energy absorbing properties to make a lighter weight ballistic material. And we have companies that are making, for example, one company in particular is making a ballistic shield, a handheld ballistic shield that will actually float on water. So that tells you about the buoyancy of it and the weight of it, and it still maintains a high degree of ballistic protection. So it's very successful in ballistic applications. There's a question about the percentages, how much graphene yarn do you need to put into a textile to make it effective? I'm going to leave that to our commercial partners because they're the experts in the blends. It depends on what textile you have. And I do know that graphene enhanced fibers have been included in synthetic fibers, but also with natural fibers, wool and cotton, to make a blend. And they would be the best to give you advice on what percentage you need, depending on what attribute you're trying to get to, if it's thermal conductivity or, for look and feel, or if it's more for strength and wear, then those differences, it'll matter what is the fiber you're blending with and what are you trying to achieve to get you at percentages. So I don't want to, there's not one answer for that, but that's best to talk to our partners like Kyrene. Yes.
And I wanted to add a comment on that too. So there's kind of two factors here, right? There's how much graphene is in the actual fiber that's being produced, and then how much is in the blend. How much of that graphene fiber is in the total blend of the material, of the end result product. So that's kind of two different questions: is how much graphene should be in the original mix for the fiber that's made, and then how much of that resulting fiber should be in the blend along with other things that might be for comfort. So there's kind of two different answers there. And as Terrence said, there's others who are experts in that who can answer that question better depending on the application. So just wanted to add that note.
And I think, Kerry, we're going to take one more question. It's a good one, but we're going to take one more question, and then we're going to conclude our webinar today as we come up to the top of the hour. Do we have the opportunity to test flame-resistant, non-flammable graphene-enhanced fabric under the Verified Manufacturer Program? Thank you. Yes, the short answer is yes. We'll test for flammability for you, no problem. Graphene, in fact, has been used in a number of products for flame-resistant materials in the construction trade, for example, to make flame-resistant products. It's a really interesting application. I'm sorry I didn't mention it sooner, but that is another potential application, is to reduce flammability of a host material It depends on the type of graphene used and the load factor, of course, but that is something we could help you with and test. And that's yet another benefit of using graphene potentially in a textile application. So with that, I hope that we've shown to you the versatility of the test methodology and the rigor that we can bring to this subject. Our end objective is to help you have a successful implementation of graphene in your application, whether it is textile, which is a rapidly growing use case for graphene because it works and it makes a superior fabric, or whether it's in any other type of application, we apply the same kind of rigor and approach to connecting qualified supply chain partners with customers. And Carrie, I want to say thank you. You know, Carrie and I have worked together for years now on this. We've learned an awful lot by doing these kind of tests and working with many forms of graphene. And I really appreciate the collaboration we have with Carrie in his office. He's extremely professional, but he's also quite personable. And I want to say, when we do the testing, we don't just send you the report. And I think, Carrie, you alluded to that. It's not like, you know, here are the numbers. Thank you. Have a good day. We will sit down with you after the testing and go through what we saw and what it means and do the interpretation. And because we see more graphene materials than probably anybody else on the planet, to be honest. And so we can also give you some context and comparison of how that material compares to others that are in the market without divulging any confidential or commercially sensitive information, but we can give you context. And I think that's a big advantage to doing testing programs with our combined offices. Carrie, do you have any closing comments?
Nothing really much to add. Just thank you all for attending. And as Terrence said, you know, we're here to support your endeavors. This is an exciting time to be involved with graphene work. It's kind of, you know, moving upward in trajectory. And so we hope to see more continue. So please feel free to reach out and we'll be happy to help support.
Thank you, everyone. We will send you a link to the recording. It'll go on our YouTube site and we'll send you a copy of the slides. Feel free to share that with whoever you think might be interested. Have a great day. Take care.